Hey everyone, it's Review Unit 12, Circles. Number 1. Given triangle CED is circumscribed about circle A. So remember, circles are named by their center. That means A is the center of the circle, and circumscribed means that the triangle is around the circle but touching on each of the vertices, which means that CF and CB are tangents. So when they tell you that CB is 10, tangents that are drawn from the same external point are congruent. So if CB is 10, we know that CF is also 10. Line segment CF is also 10. And then when it tells me that segment EF, where is that? EF here, is 8, I also know that the tangent drawn from the same external point is also going to be 8 units. So it says part A, and also, while we're on the subject here, we know that segment DG is going to be congruent to segment DB, but we don't know anything about those yet. So let's get to part A. It says angle CDE. We have to find it. Well, remember back here, we were given triangle CED. Well, we know that the three angles of any triangle, the triangle sum of the interior angles is equal to 180 degrees. So we have 2 out of the 3 angles. So it's going to be 180 minus 70 plus 40, or however you want to think about it. So 70 plus 40 is 110, and 180 minus 110 is 70. So that means that this angle is 70. Oh wow, look at this. 2 angles that are 70 degrees. Look what we just saw. We just formed an isosceles triangle with 2 congruent angles, which means the sides across from those angles, this side, CE, is going to be equal to side ED. Not sure if we need that, but let's write that down. Side CE is going to be congruent to side ED. Okay, moving on. Segment CF. Where is that? Segment CF. Oh, right. That's right over here. We said that was equal to 10 because tangents drawn from the same external point are congruent. Then they're asking for segment EG. EG is here. Oh, right. We said that this is 8 for the same reason, right? Tangents drawn from the same external point are going to be congruent. Then they asked me to find the length of segment ED. ED. So, that's going to be the length from here to here. And oh, wow, we did need that information. Didn't we say that segment ED is equal to segment CE? Segment CE was made up of tangent 10 with a length of 10 and a tangent with a length of 8. So therefore, segment ED is going to be 8 plus 10, which is 18. Awesome. Let's move to the next one. Number 2 says determine the value of x in the circle. Well, this angle is an angle formed by 2 chords, and it's in the circle but not at the center, which means we're going to add the 2 intercepted arcs and divide by 2. So I just wrote that out. An angle formed by 2 chords in the circle but not located at the center. We're going to take one intercepted arc of 70 and its vertical angle's intercepted arc of 100, and we're going to divide that by 2. So we end up with 170 divided by 2, which gives us 85. Next, they want us to determine the value of x in circle A. Well, this is an angle located outside the circle. There's actually 2 ways of doing this, but this angle is an angle formed outside the circle is equal to the major arc minus the minor arc divided by 2. So this is the minor arc, which is less than 180 degrees. So now we need to find the major arc, which is going to be the rest of this circle. So in order to do that, a circle contains 360 degrees from one starting point all the way around back to that starting point. We've used up 140 degrees, which leaves us with 220 degrees for the major arc. So to find x, we're going to take 220, we're going to subtract 140, divide that by 2. So that becomes 80 divided by 2. So the angle of x is equal to 40 degrees. This is a special angle. It's an angle formed by 2 tangents, and it's supplementary to the minor arc. So you could have done 180 minus 140 and still gotten the same answer. So a lot of different ways to do these problems. You just have to show all your work. Example number 4. Given the circle below, segment CF is 7, segment FB is 6, segment DF is 3, and it says determine the length of ED. So they want us to determine the length of the entire segment. Well, step 1, we're going to find the length from F to E. And the way that we're going to do that is we're going to take the length of CF times the length of FB. It's the part of one chord times the part of the other. And that's going to be equal to multiplying the parts of the other chord. So that would be segment DF times FE. So we're going to start out with 7 times 6 equals 3 times X. 7 times 6 is 42. That's equal to 3 times X. The opposite of multiplying is dividing. And 42 divided by 3 is 14. So that's equal to FE. So when they ask us to find the length from D to E, DE is formed by segment DF plus segment FE. So segment DE is going to be equal to 3 plus 14, which is 17. Great job. Let's go to the next one. Number 5. Encircle O, which means O is the center. So we'll label that O. Secant ADB, secant's line segment ADB, and line segment AEC are drawn from external point A, which means A has to be here. So this first secant is A here, the outer point, D, right? So the letters are going to go in order. And the other secant is A, drawn from the external point. This will be E, and this point will be C. Such that points D, B, E, and C are on circle O. If the length from A to D is 8, and the length of AE, right over here, is 6. If BD is X, well, right away, if that part is X, then I know that the whole secant is going to be X plus 8. And the length of E to C is X plus 12, and right there I'm going to say the whole secant is going to be X plus 12 plus 6, or X plus 18. Determine the length of BD. So they want us to find X. So in order to do that, we're going to take the whole secant and multiply it by its external part. And that's going to be equal to the other whole secant times its external part. Okay, so the whole secant AB times the external part AD is equal to the whole secant AC times its external part AE. So now we're just going to plug in. We have X plus 8 times 8, but I'm going to put the 8 here in the front, right? Multiplication is commutative. I can write it either way. And then, and the other side of our equation is segment AC, which we said the whole segment. Remember, we added those two pieces together to get X plus 18 times AE, which is just a single digit. So again, I'm going to put the 6 in front just so it's easier when I now distribute. So 8 times X is 8X, 8 times X, and 8 times 8 is plus 64. And that's equal to 6 times X, or 6X, and 6 times 18, which is 108. Now, there's 4 different ways to start this. I like to have all my X terms on one side, so my first step is going to be to subtract 6X from both sides. So 2 times X plus 64 equals 108, and always feel free to pause the video, try it on your own, you could always come back. I'm going to subtract 64 from both sides to get 2 times X equals 44, and then I'm going to divide by 2, and that's going to give me X to be 22, and we said X is actually equal to the length of BD. And you are done with this problem. Here's number 6. If the measure of angle CBA, this piece right here, is 20, and the measure of angle DBA is 27, determine the measure of angle COD in circle O. Okay, so that gives me a lot of information. Angle COD is in circle O. So circles are named by their center, which means angle COD is a central angle, which means it's equal to its intercepted arc, in this case, arc CD. So I need to find arc CD. So let's go back. If I lead arc CD back to possibly another angle, let's see what we have. Ooh, look at this. Angle B, angle CBD is an inscribed angle, and inscribed angles are equal to half of their intercepted arcs, in this case arc CD. So angle CBD is equal to 20 plus 27, or 47 degrees, which means arc CD is going to be twice the measure of 47, which is actually 94 degrees. And we actually just said over here that angle COD is equal to arc CD because it's a central angle. So therefore, angle COD is 94 degrees. It's like a little puzzle piece here. It's just getting easier and easier every time we do this. Number 7. Determine the arc measure of arc ED. So we're ultimately looking for the measure of this arc here. Of circle A, right, which means A is the center since circles are named by their center. And they're also telling you that BC, line segment BC with this arrow, is parallel to line segment ED with this arrow. Oh, wow, look at that. So do you guys see this letter Z? So we have alternate interior angles, right? Parallel lines, that means parallel lines form congruent alternate interior angles. It says, and the measure of angle BDE is 65. Okay, so we have a lot of things going on here. So we know alternate interior angles are congruent. We also know that line segment BD is a diameter. And diameters divide the circle into two semicircles, 180 degrees each, which means the measure from B all the way around to D is 180 degrees. Well, guess what? Angle EDB is an inscribed angle, which means the angle is half of this arc here. So angle BDE is equal to 1/2 arc BE. So that means that arc BE is going to be 2 times 65, or 130 degrees. So now we said that arc BD, the whole entire arc, is 180 degrees. So if I take arc BD plus arc ED, right, that's going to equal, arc BE, sorry about that, plus arc ED will give us arc BD. So that's where I'm getting this from. Arc BE is 130 degrees because it's the inscribed angle is half of that arc, plus arc ED is going to give us 180 degrees. So 180 minus 130, we're going to get arc ED to be 50 degrees. Let's finish number 6 and number 7, and now we're off to number 8. Number 8 says, a candy machine creates a small chocolate wafers in the shape of circular discs. Circles, okay. The diameter, which is the distance from one side through the center to the other side of the wafer, is 16 millimeters. That's the diameter. Well, whenever they ask me for the diameter, they typically ask for the radius. So right away, I know the radius is half of the diameter, so 16 divided by 2, or 8 millimeters. So now they're asking me, what is the total area of this circular disc of 5 candies to the nearest square millimeter? So I have to find the area of one of these. Well, the area of a circle, if you look on your reference sheet, is pi times the radius squared. So the area of one circle is pi times the radius, which we found to be 8 squared. So the area of one wafer is going to be, let's put this in here, 8 squared times pi is 201.0619298, but they want 5 candies. So we're going to take the area of one of them and we're going to multiply that by 5. So the area of 5 circular candies is equal to 1005.3. And they want me to round to the nearest square millimeter, which means to the nearest whole number. So I'm rounding to this 5. So my final answer is 1005 millimeters squared. Easy as pie. And now we are on to the last page. Number 9 is a multiple choice question. It says in the diagram of circle A, so remember A is going to be our center. Below, we have a chord CD, which is just a segment that touches a circle in two places, and chord segment EF, that's here. They intersect at G. Fantastic. And chords CE and FD are drawn. Which statement is not always true? Well, let's take a look here. I'm actually going to kind of skip around. And I'm going to start with choice, because CG, I'm not really sure about this. CG and FG, is that not always true? I'm not really sure. So let's go to choice 2. Angle CEG, where is that? Angle CEG is actually this angle here, which intercepts arc CF. So that's an inscribed angle. That angle is half the arc. And is that congruent to angle FDG, which would be this angle here, which, oh, look at that, it intercepts the same arc, which means these angles will both be half of that arc. So these two angles will always be true. These are inscribed angles who intercept the same arc will always be congruent. Okay, so we're looking for not always true. Okay, let's look at choice 3. Angle CGE, that's this angle here. So we know that this angle and this angle are congruent. Okay. So two arcs are on this angle. And angle FGD. Oh, those are vertical angles. Vertical angles are always congruent. So this will always be true. So let's look at choice 4. It says triangle CEG. So it's this triangle here is similar. This means similar to triangle FDG. That's this triangle here. Well, look what we just found from choices 2 and 3. We have these two angles will always be congruent. These two angles will always be congruent, which means a third angle will always be congruent. So this is true, because if you have two angles congruent to two angles, then the triangles will be similar, which leaves us with choice 1. I wasn't sure. This is not always true. It could be true, but it's not always true. Number 10, it says in the figure below, segment AB is a diameter. Okay, well, diameter forms two semicircles, 180 degrees each, of a circle with a radius of 34 miles. Well, if the radius is 34, one radius is 34, then another radius is 34, which means the diameter is 34 plus 34, and this is miles, which is going to be 64 miles. Okay, if AC is 32 miles, determine the length of CB. Okay, so we'll call that X. What do I have here? I have a triangle, and I have two sides of a triangle, and I'm looking for the third. If this was a right triangle, I could use the Pythagorean theorem. So let me see. Let's go back to this diameter. If AB is a diameter, then doesn't that mean that this semicircle, this arc AB, is 180 degrees? And if we lead that back to angle C, isn't this angle an inscribed angle? So angle C is half of 180, which is 90 degrees? Oh, wow. Okay, so angle ACB is an inscribed angle, which is half of arc AB. So that's where we're getting this from. So it's going to be half of 180, which is 90 degrees, making this a right triangle, which means the two legs are A and B, and the side across from the right angle is always our C term. So now we're simply going to use the Pythagorean theorem. So A squared plus 32 squared equals 64 squared, right? The length of AB. So the two radii added together give us the diameter, which also gives us the hypotenuse of this triangle. Fantastic. Okay, so we have 32 squared, and that gives us 1,024, and 64 squared is 4,096. So when we take 4,096 and we subtract 1,024, we end up with 3,072. So A squared is equal to 3,072. Hold on. Back up one step. I made a mistake back here, didn't I? 34 plus 34 is not 64. 33 plus 3 is 6. 4 plus 4, this is 8. I apologize over here. Let's go back to our Pythagorean theorem. I was all excited because this is just like a little puzzle piece and I find it very exciting. All right, so let's go back. 68 squared is, how about 4,624? 4,624. Sorry about this. And now, when we take 4,624 and we subtract 1,024, we end up with 3,600. That sounds much better. Okay. So the opposite of squaring is square rooting. So therefore, A, which I said is CB, the square root of 3,600 is 60. So CB is 60. So let's just go back and review that real fast. They gave us that AB is a diameter. The radius, half the diameter is 34, which means both radii of the same circle are going to be congruent, which means the entire diameter is going to be 68, not 64. And AC was 32. Determine the length of CB. So we found out that angle C was an inscribed angle, which means it's going to be half of its intercepted arc, which is a semicircle, so half of 180, forming our right triangle. So we did A squared plus 32 squared plus 68 squared. The side across from the right angle is always our C term, which is always the hypotenuse. So 68 squared. So that's where we got the A squared plus 1,024 equals 4,624. I apologize for that mistake. And when you subtract, you get 3,600. And when you do the square root, you end up with 60. Okay, one last question and you are done with Unit 12. In the diagram below of circle O, so by now you should know O is the center, diameter BC, and radius OA. So let's talk about this for a minute. All radii of the same circle are congruent, okay? So that means all radii of the same circle are congruent. So OB is congruent to OA, is congruent to OC, okay? All radii run from the center to any point on the circle, so these three radii are all congruent. It says chord DC is parallel to chord BA. Okay, so these two segments are parallel, and we talked about this in a previous problem. We end up with alternate interior angles, congruent alternate interior angles. All right, so it says if the measure of angle BCD is 30 degrees, determine the following. Well, what did we just say? We said that angle BCD, that's not the angle, is the letter Z is here. So then this angle is also 30 degrees. So if angle BCD is 30 degrees, that's an inscribed angle. It's going to be half of this intercepted arc, which means arc DB will be 30 times 2, which is 60. All right. Then look what we have here, this pink triangle. If I highlight this, actually, let's highlight this in blue. This is a radius. This is a radius. This is two congruent sides of this triangle. Look at this. We have an isosceles triangle, which means angle B is going to be congruent to angle A. So these two are going to be congruent because angles opposite congruent sides are congruent. So let's see what else we can do. It says find the measure of angle AOB. AOB. Well, okay, we have a lot of information here. That's part of it. There are a couple of different ways to do this, but one of them is that this angle is part of the triangle. So we know that the triangle sum of all the interior angles is 180. So if we take 30 plus angle AOB, that's going to be equal to 180. So 30 plus 30 is 60, plus angle AOB is 180. Subtract 60, angle AOB is going to be 120 degrees. So I'll put that in there. That's 120. Now they want us to find the measure of angle ABC. ABC. Well, we found that out already. That's 30 degrees because of the congruent alternate interior angles. formed by those parallel lines. Okay, and then it says the measure of angle OAB. Well, we found that out already. We said that was 30 degrees because angles opposite congruent sides are congruent, or you could have said base angles of an isosceles triangle are congruent. So a couple of different ways you could do that one. And the measure of angle AOB, which is the same as part A, it's still 120 degrees. So you guys are doing a fantastic job. I just want to show you, some of you I know went ahead and you did things a little bit different. You could have also found out some of these angles. You could have found out the rest of this arc over here by doing 180 minus 160, 180 minus 60. That would have given you 120. Okay. Let's see. A lot of different ways that you guys can do this stuff. So I'm going to leave you with that and not give you any more information because I'm getting a little excited about all this information. I like circles. They're like a big little puzzle piece to me. So you guys have done a great job. This is Unit 12. I hope that you are reaching out to your teacher if you have any questions, concerns, or problems. Have a wonderful day.